Hello and welcome to another short video about the Easy Spin development tools from Audiofab. Today we will be showing you how to use the Easy Spin pedal simulator and walk you through building your own effects using the block diagram editor. In a previous video we showed you the Easy Spin web-based programming tool. This tool provides a faithful simulation of the Easy Spin's FV-1 DSP and is a super quick way to get pre-built effects onto your Easy Spin. But if you want to build your own effects, you'll need to use the Easy Spin development tools provided as a Visual Studio Code extension. If you prefer to just read the docs and get started on your own, there is a comprehensive set of documentation available online. But there is a lot of functionality provided in the extension, so in this video we'll focus on the simulator and block diagram editor. We have created a folder in which we're going to store the effects we will create, so let's go ahead and open that with VS Code. In a previous video we showed you how to install VS Code and the Audiofab FV-1 Programming extension. Once the extension is installed, you will have a new Audiofab badge on the left-hand toolbar. Clicking this badge shows the Easy Spin Quick Actions and Pedal Simulator. We can use these quick actions to create a new block diagram, the starting point to creating your own effects, and the pedal simulator lets you hear exactly what they will sound like in real time. Recall from the last video that it is recommended to dock the pedal simulator on the right side of the window, since toggling between the File Explorer view and the pedal simulator can be tedious. It will also make creating your own banks of effects easier in a future video. Make sure the view is pinned by right-clicking the title bar and ensuring the tab has a checkmark beside it. If you lose the pedal simulator view at any time, you can always show it again using the command palette. To show the Audiofab commands, press Ctrl-Shift-P to show the command palette and type FV1. You will find a command to show the pedal simulator view. Note that you can zoom the pedal simulator in and out by holding Ctrl and scrolling your mouse wheel. The simulator is the same one we saw in the web-based programmer. It has the ability to populate the 8 slots of the pedal with any combination of effects and the same audio clips and mono stereo switch for auditioning audio through your effects. Let's create our first effect. From the Quick Actions view, click New Block Diagram. Give your effect a name and save the new .spin diagram file in your workspace. The block diagram editor gives you a zoomable canvas on which to build your effect. You build effects by wiring blocks together. Selecting a block pops up the Parameters view. All blocks have parameters which you can adjust. Here we see the ADC block has a parameter for which ADC to read from, and a selectable gain. You never have to save the .spin diagram file as it saves to disk every time you make a change. The generated DSP code is always live and ready to process audio in the simulator. Since this simple program just takes audio from the input and sends it to the output, it is effectively a pure bypass program. To demonstrate that it is processing audio, we can change the gain of the output and hear the result. Every time you make a change to the diagram or to any block parameters, the DSP code is regenerated and instantly reloaded in the simulator. If you want to move a block, just drag it to a new spot. To move multiple blocks at once, Control-click them or Control-click and drag a lasso around all of the blocks you want to move together. Now let's add a simple stereo reverb effect. Delete the existing wire. From the Tools panel, drag a second DAC output onto the canvas and change it to the right channel. Let's toggle the File Explorer pane to give us some more room. We're also going to want a potentiometer for control, so let's add one. Notice that there are 3 potentiometers. Whichever one is selected is shown in the block label, just like the ADC and DAC blocks. Now find the simple reverb block in the list of effects and drag it to the canvas and wire it up. We can start the simulator, but it will not output any sound because we haven't fully wired up the effect. Once you make the final connections, it will pass audio through the reverb. Let's add a second potentiometer so we have control over both the reverb time and the amount of dry and wet signal. Now we can experiment by adjusting the parameters. Anytime you make a change to the parameters, the DSP code is regenerated and the simulator is reloaded. Whenever you connect a potentiometer to a control input, the value of the parameter it is controlling is taken as the upper limit. So for pot 0 controlling the reverb time, it will swing from 0 to the parameter's current value of 0.5. If we want the pot to adjust over the entire range, we need to set the parameter value to the maximum. This behavior should be consistent for all blocks provided by Audiofab. Every parameter also has a Reset to Default button. You can also type values directly into the text field of most parameters to set the value. Many parameters are related to delays and will consume delay memory. There is only 32K of delay memory, so this is a precious resource when stacking effects. The resource usage indicators in the footer show you how much program memory, how many registers and LFOs, and how much delay memory is used by the current effect. As I adjust this room size parameter, you can see the delay memory that is used adjusts accordingly. Now let's take a look at the generated DSP code. Each block will generate FV-1 assembly code representing its contribution to the signal processing chain. This read-only editor is Audiofab's Spin Assembly Editor. You can see the features it provides for those of you interested in editing assembly code. Not only does it provide syntax highlighting, but it also has helpful tooltips documenting instructions, and features control-click code navigation features to go to the declaration of a variable or delay memory. Because this file is generated from the block diagram, it is read-only, but you can simulate raw assembly programs as well and edit them live. Here we will generate a simple pass-through program and copy the assembly to a new assembly file that we will run in the simulator and live edit. This is the equivalent assembly for a mono pass-through. Let's copy this into an editable file and run that in the simulator. You can see that the file being simulated follows the active editor. Like the block diagram, there is no need to save this file. Its contents are constantly being assembled and loaded into the simulator in real time as changes are made. If there is an error in the file and it is not a valid program, the simulator is not reloaded and an error is shown. Note that we can combine effects any way we want as long as there are enough resources available. For certain combinations, this will require balancing delay memory allocated to each block, and some blocks consume much more program memory than others. Feel free to experiment and build something cool. Thanks for watching.